Hello and welcome back to OpenShift's Data Services Office Hours. I'm your host, Frank Vigne, the global go-to-market lead for data services here at Red Hat. Now, today I wanted to kind of, continue to kick off the fresh start, the new year, with a general overview of Red Hat OpenShift Data Science, or you'll hear me refer to it as RHODS, and how it provides a collaborative environment with powerful open source tools that's both scalable and flexible and has integration with other tools. So put your seatbelts on, because where we're going, we will need roads. Sorry, I couldn't resist the pun. All right, so first let's take a look at the kind of the overview slide deck here for roads. It's important to get a background of what generally I mean when I talk about roads and how it fits into a much larger story we have here at Red Hat. Really, Red Hat helps customers build, run, and manage applications everywhere, right? We are the open hybrid cloud, right? And this runs from anything from traditional end-tier applications, cloud-native microservices, ISV apps and cloud services, as well as data analytics and AI/ML. And all of this is based on top of Kubernetes, but not just Kubernetes, a fully managed, a white glove experience that is OpenShift. And OpenShift could run on any type of hardware that can support Linux. And I say any type of hardware because I don't want people to pull out their old Tamagotchi virtual pets from the 90s, although I'm sure somebody somewhere has made it work there. But ultimately, it really doesn't matter where you have hardware, right? You can have physical, you can have virtual, it can be private cloud, public cloud, or as we're seeing more and more increasingly, at the edge. And this is a self and fully managed application environment. So when we talk about self-managed, we basically mean you run it on-prem and you manage a lot of the work for you. Although we do also have a fully managed option, so it's like getting a private driver, right? That top of the line experience, right? Not just the luxury car in your favorite rideshare app, but it being driven. It comes to you, it takes you where you want to go, and you don't have to worry about any other details, such as the oil changes, gasoline, that sort of thing. So Red Hat OpenShift exists here, and it's not just another data science platform. It's not just another way to run Jupyter notebooks and do data science experiments. It runs on top of an existing, well-known, and trusted enterprise-proven platform that is OpenShift, right? So it runs on top of, again, this solid foundation. And not only that, this solid foundation provides you with a number of deployment options, right? From physical machines to virtual machines on-prem to any of the major hyperscalers, AWS, Microsoft Azure, IBM Cloud, and Google Cloud. So you have this ability to run just about anywhere. Now, OpenShift Data Science, or RHODS, is based on the Open Data Hub project and operate first. So what is Open Data Hub? Open Data Hub is the community-driven upstream open source project demonstrating how to build and architect an AI and machine learning platform that runs on OpenShift, right? How it runs on a containerized based platform and is comprised of open source projects. Operate First is a subset of Open Data Hub, operated at scale for community and university type use cases to add operational excellence. Red Hat OpenShift Data Science Cloud Service is a subset of Operate First. And it exists as a cloud service on Red Hat OpenShift Managed. So think of ROSA, or Red Hat OpenShift Service, on AWS, with optional offerings with ISVs. And we'll talk about our partner ISVs in a minute. And finally, and this has really been a game changer for a lot of our customers, is Red Hat OpenShift Data Science Self-Managed. And basically, this is a fast-moving software stream that mirrors the release frequency and capabilities of our cloud service, but delivered in a self-managed offering for your on-premise needs. Now, this is important, particularly for data science, and in that when you train your models, you have to train your models in a way that respects user privacy, data sovereignty laws, and any other regulations that come with it. So what we're seeing with a lot of customers, and I'll switch to the whiteboard here, is there's a little bit of a glitch there, but we'll work around it. What we're seeing with a lot of customers is that they have data. They have tons and tons of data. And a lot of this data may contain PII. And there's been a real hesitancy for reasons large and small, regulatory and non-regulatory, is that they hesitate to put this in a cloud. And there's my terrible handwriting for you. So what we offer at Red Hat OpenShift Data Science is that you could run, now you can run RHODS. I wanna have a red pen for RHODS, because of course. You can run RHODS on the cloud, and you can now run RHODS on-prem, right? So now you, as a data scientist or data engineer or a business decision maker or a technical decision maker, now have the option of doing your training on-prem, right? And then deploy to the cloud or deploy on-prem or at the edge. So what this really does is this opens up a new or so many more possibilities for organizations that, again, for regulatory reasons around data sovereignty, data privacy, could not use a service, a native cloud service from a hyperscaler, right? The native cloud services on hyperscalers are fine, but you have to, one, run in their cloud, and two, once you get their data into that particular cloud, well, you're committed, right? And what this allows you to do, if you build on top of OpenShift, I'll go back to this slide here, right? You have all of these clouds at your disposal, right? So whether it's actual physical hardware, virtual hardware, or any of the hyperscalers, your code will be portable. Now, obviously, data has gravity, and there's some things that need to be worked around that. But the core of it is you're not locked in to any one particular vendor. You have ultimate flexibility. And again, kind of stole the thunder from this slide here, but it's a hybrid cloud platform, and it lets you access Red Hat portfolio and other services. Plus, we have a rich partner ecosystem. And you have this ability to do this in a hybrid way, whether it's you want to train some very sensitive data sets, you do that locally. If you have some very compute intensive AI and model training that you want to do, you have the option of using a hyperscaler and then bringing that what you trained there down locally and maybe do some refining. I think a great example would be a large language model. Large language models, if you're going to start from scratch, do require intensive amounts of compute. But if you wanted to have a more, you could start with a existing large language model, do some training on public data, and then bring that model down to your own data center, your own private cloud, and then do some additional training there. So the private data, the sensitive information, never has to leave your cloud. And then once you have that model built, well, that model can go anywhere, based on whatever restrictions around that. But generally speaking, it's the data that has the PII, the extremely sensitive data. The model itself is not necessarily going to have anything that is sensitive or could cause problems if that goes shared out. So let's talk about kind of our partner ecosystem here. You'll notice a lot of logos on here, right? And not just the hyperscalers. We have a partnership with Intel. We have a partnership with NVIDIA. We have a good partnership with IBM Watson. And you'll see we also have partnership with Starburst Galaxy, Anaconda, Pachyderm, and a PyTorch, TensorFlow, and all of this all of these partners make our product better, right? It is a true collaborative community and partner ecosystem that we have here that work in both cloud and in self-managed or on-prem environments. And this is really kind of an example of what a model operational lifecycle would be. You uh, unlock the value of your data by making it fast and easy to get data across to a hybrid cloud with Starburst. You can use Pachyderm to bring data versioning and governance into this very precious asset, your data, right? Your data, your raw data has a certain amount of value, but when you start putting work into it and refining it, it really starts to gain even more value. Anaconda is a extensive set of data science packages that you can use inside your Jupyter projects. You can also use Watson Studio to build, run, and manage AI models at scale using Watson ML and Watson OpenScale. We have a partnership with NVIDIA, so you can use GPU-enabled hardware to accelerate your data science projects that use neural networking. This is really important that we have the integration here from the hardware on up. We also have Intel OpenVINO notebook images, and it's a toolkit of pre-trained models optimized for Intel processors and GPUs. And we also have integrated with Intel OpenVINO Model Server, which is a scalable, high-performance model serving engine. So all of this, you can use all of this. You can use none of it. You can pick and choose which parts you want to use that fits your need. That is really the power of open source and Red Hat, right? We work with all of these partners. We're neutral. We don't have a preference to one particular hyperscaler or another. This is not something you would get anywhere else. So with that out of the way, let's talk about what the dashboard interface is, and we'll get to this in a minute because there's some cool things I want to show you. So ultimately, this is what the dashboard user interface looks like. If you're familiar with OpenShift, it's very similar to kind of what that would look like. We also have additional resources, but I want to talk today. I actually want to tab over now and double click on this notion here of data science projects and workbenches. So you'll see here, I don't have any projects here assigned to my workspace. Now, normally when if you watched me demo before, either, well, not really on this platform yet or on this channel, but on other places that I do live streams, you've seen me demo Red Hat OpenShift Data Science. And usually what I'll do is I'll just kick off a notebook server right from here. I'll pick my preferred image and if I want GPUs or not, and then I'll just hit go, right? Now, that's not always so simple. The lone wolf data scientist does exist. However, realistically, data scientists tend to work in teams and they tend to work on projects. Now, this is really the key here because now I can create a data science project and I'll just call this, Frank's demo project. And I can add a description. This is for the live stream. All right, so now that I created a project, inside of projects, you have the idea of workbenches. So what I can do here is I can create a workbench, and I'll just call this Frank's notebook NB, right? Now watch this. I can now pick a particular image. So what this lets me do is I can create a workbench for individual members of my team, and we can kind of work on that. We can work on it collaboratively, or we can work on it separately. We can create separate workspaces, or I can, or both actually. So say I have, say I'm really into TensorFlow. I just love TensorFlow. So what I can do now is I can set up the container size. Say I want to start from the base TensorFlow image. And if I go here, I can create new persistent storage. These are all my options here. Now I'm going to create a workbench. Now that workbench is starting up, it's spinning up. Now, let's just say I want to try another notebook, and I'll call this Frank PyTorch. And I can go down here and say PyTorch, and I can change the parameters here. I can make this a larger cluster, each with different ones, each with different storage. There's the name. I hit create. Now I have 2 notebook servers running at the same time, each with different versions of the software running. So if I have a particular user that is using TensorFlow exclusively, then that developer can have their own instance that runs there. I can also create another workbench of, let's see, I'll call this John Doe notebook. Say John Doe is a member of my team. And what is the problem? I got to pick an image. Well, let's just say John Doe likes his standard data science. We click go. So I can have this collaborative experience. And here's the key. The RBAC is tied to the cluster. Now, in the future, we'll talk about some Red Hat futures, Red Hat OpenShift data science futures in a minute. But if I need to have, say, a secret project that only me and John Doe have access to, or Jane Doe, right? If there's three data scientists on the team, Jane Doe, myself, and John Doe, if I have a project that I really only need for sensitivity reasons or whatever, I just need myself and Jane Doe. Right now, I have to set up a separate RHODS, a separate cluster, and use the RBAC and the authentication built into that. In the future, in the future of RHODS, that is going to be fixed. So I'll be able to control, very fine-grained control on this one cluster of who's able to access it. Now, that is a good segue into RHODS futures. All right, so where do we stand here? Well, what's coming up next, we have it broken out into 2 categories. The first half of 2023 and the second half of 2023. So in the first half of 2023, you'll see that we'll have ML Ops as being a big part of what the product is going to have added to it. We'll have enhanced model serving and monitoring. We'll also add model experimentation. So that means that we're going to support VS Code. We're going to support R Studio. And what that really means is that when you think of those workbenches, when I go here and I create a new item on my workbench, I can now say, I want a workbench that is Visual Studio Code. I want a workbench that is R Studio. So you'll see that we're really taking this to the next level in terms of flexibility and use cases. We're going to update the out-of-the-box notebook images. We're going to have we're going to start doing model explainability, so you'll be able to explain or have some kind of insight or explainable AI into what decisions why the models that you're creating are making the decisions that they're making. That's critically important in use cases around fairness and ethics, and in some cases it's even required by law to have some kind of explainability. We're going to add Intel Habana support. We're also going to have data ops with RHODA integration. Have not spoken much about RHODA, but you're definitely going to love it when you see it. We're going to have platform capabilities, disconnected support. That's already here, right? So you'll be able to run this on-prem, either disconnected or completely disconnected, air-gapped or not. And then we're going to have enhanced UI configuration. So we're already delivering on that. So what's next for the future? So again, MLOps, not a big surprise. That is going to play a big role in any data science project going forward, because that really is the future. And unfortunately, Red Hat knows a thing or two about DevOps, and arguably MLOps is really a machine learning or AI flavor of the DevOps process. So we're going to have enhanced model serving and monitoring, data science pipeline enhancements, and to be determined what our model registry will be. Perhaps we'll have something to say about that at Red Hat Summit, but my lips are sealed for now. And we'll also add more model experimentation features, right? We're going to enhance the collaboration capabilities. That's the role-based access control to these various workbenches is basically what that is. We're going to update, again, we're going to continually update these raw out of the box notebook images and custom notebooks phase 2. That's also to be determined. My lips are once again sealed. We're also going to work on the data ops side of things with data labeling. And in terms of platform capabilities, it will be coming to ARO, which means all you Azure fans, you'll be able to run RHODS natively on Azure. And that means that this will be an Azure marketplace, right? So you can just click through, do a search, say, Red Hat OpenShift Data Science, and boom, it will be there, and it'll be that. It'll be click, 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 and you'll be able to do that very much the same way it is on AWS Marketplace today. And again, we're going to continually improve the admin UI. So that having been said, I think the future looks bright for RHODS, and you have a great. All right. So with that in mind, you can see that the future of RHODS looks bright. It's already bright. It's just going to get brighter. So next time, we'll have a guest and think of some good questions. Let me know if there's something particular you would like to see in the comments below. If there's something particular you would like me to see demonstrate, whether that's image generation or computer vision projects. I do have a demo I'm cooking on using OpenCV, but it's not quite ready for showing. But definitely we'll look forward to sharing that at a future date. But with that, I'm going to end this stream. And again, if there's some particular technology or particular question you want me to address, or be a guest on the show and we can talk about RHODS, feel free to let me know in the comments below. Once again, I'm Frank Vigne, and thank